Okay, that should be enough time. Either you know these or you don't. The most common mistake on number 2. This is a mistake I'm going to write. Is to say that's 9 to the 3rd power. And I always have to be a dork and say, where do you see 3 nines? I don't see 3 nines. So when you are collecting exponents, you are not actually doing the multiplication yet. You're just collecting how much multiplication you eventually have to do. I got 1 3 multiplied by another couple of 3's that are multiplying. How many whats do I have to multiply still?
3 times 20, or 3 times 9.
I still have 3 3's to multiply eventually, right? Now please, dear guys, I need to see application of properties of exponents. Don't just say this is 3 times 9. I need to see collection of exponents, and then you can say, what is 3 cubed? 27. I like it. So of course, what property am I using when I multiply like bases? I just add the exponents. The base doesn't change. You can't suddenly have a different number of things that weren't even there. I don't see any 9's up there. You guys, so far so good? When I throw a number as the base, it kind of throws people off. But I'm not actually multiplying anything yet. I'm just keeping track of how much multiplication I eventually have to do. Okay, maybe. What about number 4?
12.
Good. 3 times 4 is 12. It's amazing. X to the 7th. I like it. If you said x to the 10th, be careful. There is no 2. There is no 5. Right? There is no spoon. You have 2 x's, a couple, 5 more x's, so now you got 7 x's multiplying. That's why the property is that. You're just collecting how much you got to multiply. I like it. Is that cool? It was all right. You guys had a good weekend?
Yeah.
Some of you guys a little too good, or a little too bad. I don't know. They very often look the same. What about this guy here? 2. We got 5, 6 more is 11, 9 more is 20 of these suckers. I like it. Stay with me now. So that's all a lot of these properties of exponents are, just collecting how much I've got to multiply. What about number 5 here? Yeah, what's the base? And how many of them do you end up with?
6.
There you go. This would be x plus y to the 6th. This is definitely not equal to x to the 6 plus y to the 6. Holy shit, no. You gotta cross through it. No. What are exponents based on? What are exponents based on? What operation? Multiplication. So they will not play well with addition. You have to write this sucker 6 times and start to FOIL it till you go insane. So I'm not going to make you do that. You just have to say this. Yes?
I have a really good question.
Good.
How did you get 27 for 2? 27?
3 cubed means 3 times 3 times 3. So what's 3 times 3?
Okay.
Yeah. So 3 cubed means 3 times 3 times 3.
Gotcha.
Sweet. Yes?
For that same one, if I did 3 times and then 3 times 3 is 9, and then 3 times 9 is 27, is that the wrong way to do it?
Sort of. I need to see an application of properties of exponents. At the end, you can simplify it if possible.
Okay.
But don't simplify it in the middle. I need to see 1 plus 2 is 3. I need to see that exponents rules. I like it. Yes?
I'm still thrown because you have 3 times 3 is 9. You have 3 x times 4 is 12 x. I'm confused why the top one says 3 still, and then like here are 3, and then 1 plus 2.
Of course. All right. So you ready? Here we go. 3 times 4 is 12. 3 times 9 is 27. But when I'm using properties of exponents, I got one property is collecting how many of the base you got. I got 1 3, 2 more 3's. I got 3 3's. Here I got 1 3 and a 4. I can't collect those. I can't. They're not like enough. They have to be at least like bases. Multiplication doesn't need exact like terms, but it does need something, right? But 3 times 4 is 12. Great. I could make it 3 times 2 squared. That doesn't do really anything for me. I can't collect them together because they're not like bases. I like it. Okay. Anything else on those 3 right there? And again, just to look at this a little bit deeper here. If I have 3x squared times 4x to the 5th.
What about 7?
We'll get there. Look at it number 4 again, a little bit closer. We have this beautiful property that we love to hate early on. It's commutivity. I can't do 3 times x squared. But I can do 3 times 4, so I move them around. Now, do I actually write this? Hopefully not. Hopefully you don't have to. But this is what we're actually doing. We multiply the numbers because we can. We collect the x's together because we have a property that tells us how to do that. Yes? Cool with that? So we got to line up on a Monday morning. But oh, well, keep going. Number 7. Careful. How many R's do you see total?
7.
7. How many S's do you see total? 4. 4. Bam. It's the same rule. It's the same exact rule as this one. It's just I got an R and an S that I got to collect each of them separately. Right? I can't put R's and S's together, but I can put R's together. Is that cool? And someday, let me see. How do you do this? 2R plus 3S plus 5R plus S. Yeah, I see 7 R's adding, and I see. So do you see the similarities here? Exponents, multiplication. I see 7 R's multiplied by 4 S's multiplying. Here, I see 7 R's added to 4 S's adding. Yes. So coefficients are go with addition, the same way that exponents go with multiplication. The analogy is really, really nice. Do you ever have to actually do this for yourself? No, I'm just trying to show you that it's just collecting terms, right? With addition, it's like terms. They have to have the same letters and so forth. With multiplication, it's like bases. But they're the same idea. Okay, cool. I got you. So what about, let's see. Who remembers what anything to the 0 power is? 1. Sweet. I got no 15s, so I just got a 1 sitting there. So what about number 2 there? Anything to the 0 power is 1. Done.
The rest of them as well.
Look at number 4 though. The top becomes what? That's crazy. And the bottom, it's just a 9 still. Why doesn't the 9 become a 1? Because the 9 is not raised to a 0 power. So why would it do that shit?
5 and 1.
What's anything to the 0 power?
It's not
Okay.
0?
No. So this is where we started, right? Anything to the 0 power is 1. Just to remind you guys. Is that cool?
Yeah.
Okay. Just a real quick reminder. X squared divided by x squared. What's 2 minus 2? 0. So that is officially x to the 0 by the properties of exponents. By the properties of exponents. What's x squared divided by x squared? What's something divided by itself? Freaking 1. Okay. Anything to the 0 power is 1. Except for 0, we're not even going to go there. 0 to the 0 is freaky as hell. Can't analyze it until you get to calculus, so let's not do that. What's 0 to any power? What's 0 squared? What's 0 cubed? What's 0 to the 287th power? 0. And what's anything to the 0 power? 1. So what's 0 to the 0? You got competing things. That's just freaky. That's the last thing I'll say about 0 to the 0. So anything to the 0 power is 1, except for 0, but I'm never going to do that to you because it's too freaky. It's kind of related to 1 divided by 0. That's freaky enough. This is like on the next level of freakiness. Take your word for it. So what about number 3 then?
2.
Good. You got 2 times, what's anything to the 0 power? 1. So you got 2. So the power can only act on which it is sitting. It's sitting on the 1/3. So that becomes a 1. But the 2 is just sitting there. 2 times, I don't know yet. I like it. Okay, what about these here? What's x to the 10th divided by x to the 4th?
X
It's a 6.
Beautiful. The same reason that when you multiply strings of them together, they get longer strings. When you divide, you're cutting off parts of the string, cutting off part of the chain. I had 10 x's chained, and then I divided 4 away, so now I got 6 x's. Not a big deal. So, of course, this would be
Y to the 3rd.
beautiful. Become a 3. Okay. Yeah. Look at number 4. What would happen with number 4? Yeah, I got 5 3m's. I divide 4 3m's away, so now I'm left with
3M.
a 3m. Don't do that, man. And then look at number 5. Ooh,
Yummy.
it is so yummy. Alright, let's wait. So guys, watch. The people that are really good at math, naturally, they just naturally are able to break things up. You know, like, good for them. Some of us aren't born with that in our brain, so we got to force ourselves. The first part of this problem is freaking easy. What's 3 over 12? 1 over 4. Yes, you just reduce it. And then, see the x's. Let me see if I can do this. No, I can't. Oh, the x's are their own little problem. So I got 1 over 4. Yeah, I got x cubed over x squared, which is what? X. Y8 over Y4. Yeah, there's 4 y's left. And then I had 2 z's. I divided 1, so I got 1 z left. Whoop-de-doo, right? If you're able to just break it up, do the numbers, do the variables as they come. That is 4 easy little problems all together in one ugly-looking problem. All right, fine. Now, real quick, I always get this question. I always get somebody that eventually tells me this is -9.
What?
Exactly. If you were the teacher and somebody put -9 for 3 over 12, what are they thinking? They're thinking subtraction. What the hell do you subtract of? Exponents. So then I get the question, well, why do the exponent numbers act different than the number numbers? Well, you just answered your own question, sort of. They're different things, right? If I wrote numbers in the same way, so tell me out. What is 3, let's do it this way. What is 27 over 9? That's amazing. Now write 27 as something to a power. What would that be? 3 to the 3rd. 9 would be 3 to the 2nd. Now that I've written it in exponential form, it will act according to exponential rules. What's the rule here? Subtract. So I end up with a single 3. I get the same damn answer. So if they're written as numbers, we've known how to deal with numbers for a long time, hopefully. If they're written as exponents, then we know how to deal with exponents. But the answers have to come out the same. So please, dear God, don't start saying 10 over 5 is 5, because 10 minus 5 is... No. It's 10 divided by 5. It's 2. Stop it. We know how to deal with numbers. It's the exponents that act differently now. Okay. All right, what about this here? What happens here?
X to the 10th.
The 10.
I like it. I've got 5 groups of 2x's. So never write this. I'm going to write this once more here. That would be x squared times x squared times x squared times x squared times x squared. Right? That's what something to the 5th power means. And of course that would be 2, 4, 6, 8, 10. So why do this shit when you just realize, oh, that's the definition of multiplication. I got 5 crates, and each crate has 2 apples. How many apples do I got? 5 times 2 is 10. So I got 5 groups of 2 x's. Of course I got 10 freaking x's. Please let that be nice. What about number 2? Yeah.
So even if it's a letter, it would still just be 1?
Of course, yeah. That's where we started things, right? Remember? X to the 0 is 1. That's how we proved it. Yeah. Anything to the 0 power is 1. So I have been known to be evil in certain places, and I'll give you like this huge, ugly-looking problem that's not even written well, and blah, blah, blah. And X to 17 to 14, Y to the 137. And then I'll put it to the 0 power. So people start, when anything to the 0 power is 1. That's a check mark. So now please do not understand. I think that was like in a bonus section or something. You with me? I'm not going to do something like this so that if you don't notice and you start working on it, you just lose time. Hopefully you understand I'm not like that. Give me a few years. What about number 3?
Y to the 36.
Y to the who?
36. Oh, 30.
30.
So confidently.
I know. It's like, make up for it with confidence. 36? Check your math, Jeff. Okay, how are we doing so far? I mean, this is kind of quick, but this is really a review of what we did last time. What happens here? Good. This is called power distribution. Why am I able to just distribute the power here? Because what's the operation on the inside? And exponents are based on multiplication, so they will play well with multiplication. So I get 5 cubed, x cubed, y cubed. What is 5 cubed?
125.
125, I like it. So you need to start knowing your squares and your cubes. Cool? 7 squared is 49, 8 squared is 64. You got to do the same thing with some cubes, maybe up to 5. If you need to know 6 if you want to. This is going to help you a lot when we get to factoring. Factoring algebraic expressions. All right. Here, you guys do number 2. Lipsy, are you out there? Hey. So hopefully you guys aren't doing 2 times 2 times 2 times 2. Because is this part being raised to the 10th power?
No.
No. It's just sitting there waiting. And then I get x to the 20th, y to the 30th, and then z to the 10th. Number 3. Please excuse my dumbass, I will help you out tremendously. Get your ass out. You guys think if I use in the future, if I use, please excuse my deficient algebra skills, would that be, would that be offensive? It's just please excuse my deficient algebra skills. All right, what do you guys get? Now, what do you guys got to do first? Why did I say the PEMDAS would help you?
Because it's in a parentheses.
What did you do last?
Multiple together.
You multiplied last here. Because the other thing you have to do is exponents.
Yes.
Do exponents first.
Yes.
They're not like bases, so you can't just combine them to make 7 power up there. It doesn't make any sense. So you have to figure out what this is so you can multiply by whatever the hell that is. So what is 2x squared cubed?
2 cubed.
Careful, yeah, 2 cubed is
8.
8.
X.
X to the 6th. Okay, that's the first pieces. Everybody with me now? 2 cubed is not 2 times 3. They have to be different, or else why would they both exist? How are we doing so far? Is that? Say again? So 2 cubed is 2 times 2 times 2, which is 8. And then x squared cubed is x to the 6th. Over here you get 3 to the 4th power. What's 3 to the 4th power?
12.
Careful. 3 cubed is 27.
Oh,
84.
There's more. One more. X to the 12. Now I can do this.
648.
648. X to the
18.
18.
Yes.
Alright. Relatively, number 4 should be easy. Relative to what we just did. What do you do with number 4 there?
Multiply -2 times -2.
Yeah, -2 squared is, careful.
Positive 4. M
If
squared.
I have an even number of negatives, they will all kill each other. So it becomes positive. M squared, n to the
8.
8. Please, dear God, if you have any troubles with any of these that we've gone over, these are the basics. What we just did, right? These are the basics. So if you have trouble with these, we're going to be building on these. Okay, just to show you. Oh, well. I think we did a few more. Oh, yeah, that's right. I don't have a nice problem with what I want, so I'll make one up. Let's do one together. This is the worst one I would give you on a test.
You couldn't just put a 0 there, Jim?
Nope. I mean, I could. 0. I know. So again, what's the last thing I'm going to do in this problem?
Multiply it by 2.
Yeah, square it, right? Because good old please excuse blah blah parentheses. I'm going to do inside. Some of my colleagues say to go ahead and do the squaring it. I'd rather have less shit to square. Plus it follows order of operations. I personally don't understand. So inside, what do I get the numbers?
5.
5, that's crazy. Now watch this. People freak out about it. Let me show you. I never really bring negative exponents in. How many x's cancel?
-3.
No. How many x's cancel?
2.
2.
So after 3.
You guys see that? There's 2 up top. It's going to cancel with 2 down below. How many are left?
3.
3 where?
Below.
bottom. Now I could do 2 minus 5 is negative 3, and then you have to flip it, and then eventually you catch up with us. It's a 3 on the bottom. But doesn't it just make sense? If there's 2 up top, 5 on the bottom, 2 cancel, you have 3 left on the bottom. You have, where are they left? Wherever there was more of it to begin with. Please let that make sense. So I'm not saying negative powers are bad. I'm just saying that's where we can make mistakes easy. So if I don't have to bring them in, why would I? So where are there, how many left of the y's? 3 left on the top, because that's where there were more of them. 1 dies, and there's 3 left up there. And the z's?
2 on the bottom.
2 on the bottom. So if you want to bring negative exponents in, I'm not saying you'll be wrong. I'm just saying it might be easier for you to make mistakes. Is the inside all done? Yes.
Forgot.
So now I can do this. So I just square each one. What's 5 squared? Y to the 6. X to the 6. Z to the 4. When you raise something with a power to a power, you multiply. When you multiply like bases, you add. Let me say this. I always try to say this. Maybe if you guys don't understand what I mean. Do you guys see it's always like one level up? When you multiply like bases, you add. When you raise things with powers to another power, you multiply. I don't know if that made sense. I always try to say that. Okay. So let's do something new. Well, this is not really new, to be honest, because I threw this in there with the rest of them. What's a negative power mean? So what's 8 to the negative 1?
You have to flip it so it's 1/8.
Good. So I really, guys, so I really want this to make sense. Obviously. But exponents are based on what again? Multiplication. So a negative exponent should mean the opposite of what it's based on. Does that? Coefficients are based on addition. So a negative coefficient means you are subtracting. Is that cool? 5x minus 2x. The 2 is negative, you're subtracting because it's the opposite of the operation it's based on. Is that? And again, I'm explaining a little deeper than I have to. Guys? Right? So you can just remember a negative power means flip, but I kind of want you to see why it makes sense. Of course, we proved it the other day. We proved the fact that the negative power means flip. But why does it kind of make sense? Because a negative powers are based on multiplication. It should be the opposite of multiplication, division. Or in this case, like the reciprocal, right? So what about number 1?
It's
1 over 2 to the 4th. I like it. Those 4 2's flip down.
16.
And then 2 to the 4th is 16. So it's 1 over 16. So you think about it. What's 3 squared? What's 3 squared? 9. So what's 3 to the negative 2? 1/9. Like a power can never make something negative. A power can never make something negative. A power can flip something. Sure, that's what a negative power means. All right. So what about number 4 there? I like number 4 a lot. What's being raised to a negative power number 4?
A or B.
B is.
Oh, so it's A over B.
So A stays, the B goes down. Yes, ma'am. Number 3 is just like number 1. So what would number 3 become? 1 over. So guys, I know this is kind of a corny way to say it, but if it's a negative power, it doesn't like where it is. So it goes downstairs, now it likes it there. it becomes positive. I love it. That's the right reaction. But whatever the hell sticks in your brain and helps you remember this stuff, right? Some of you guys are looking like X's are happy. I love that. I know. Guys, help me out with this one. What happens here? I don't see any nines. What do you do with the powers? Oh, all right.
Subtract them.
All right. All right. Quiet. Guys, everybody, you guys especially. All right. When you have like bases and you multiply, what do you do with the powers? Add them. What is 5 plus negative 7? Negative 2. Now, listen, guys. Never take it personally if you're the one person saying the right answer amongst a lot of wrong. My ears can only do so much, right? So if you said the right answer, enjoy it, love it, feel good. But so 5 minus 7 is negative 2. Now that's not done. 1 over 3 squared, which is 1 over. I like it. So another kind of way to look at this, I had 5 3s. Somebody took 7 away, 7 3s, so I'm like 2 3s in the hole. I'm 1/9. So it's another kind of way to look at this. When I got negative powers on something, that means I got 1 over that. I'm like in the hole that much. I don't know if that'll help one person. That's 1% at a time. Sure. Yes. Got to know when to hold it. Oh my gosh. Mondays, I love it. What about number 6? Yeah, so this will be x to the negative 9, because 1 minus 10, which is 1 over x to the 9th. I like it. Now, the mistake you guys made on number 4 was not being careful with what was going to be flipped. The only thing that gets flipped are the things that are to a negative power. So what about number 8? Now it's 1 over a to the 4th, b to the 4th, either way.
Oh, okay.
So you got 4 a's and 4 b's. You got 4 a's. How are we doing? Oh yeah, so much time left. Don't even look at it. Let's see what's interesting here. Oh yeah. Do number 9.
Are you letting cross cancel on Exponents?
How do you mean? What's?
Yeah, I think I wrote it wrong.
All right, guys. So you saw one just like this earlier. I've got to do each little piece here first, right? What happens here?
X to the negative 6.
Yeah, x to the negative 6. Y to the third, I like it. The basic properties of exponents never change. There might be negative numbers up there. There might even be fractions up in the exponent. The properties don't give a shit. In fact, no property ever gives a shit about what's there. They stay the same. So the process when I raise something with power to a power is you multiply the powers. Same thing happens over this little chunk. I get x squared, y to the
Negative 4.
And now the process when I have like bases multiplying, I can add the powers. So I get x to the
Negative 21. Oh, sorry. Sorry.
x to the negative 4, y to the negative 11. We're not quite done with this yet, but let me stop there. So again, order operation saves you. Oh, we're at dusk. And what's the last step here? 1 over. 1 over. So 4 y 11.
So it's always going to be 1 is going to be always the numerator.
Yeah, because, guys, help me out. Guys,
Yes.
so 2 things. Guys, if there is something that is not to a negative power, it is not going to flip, like on this problem over here. Right? The A stayed on top, the B flipped because the A is not to a negative power. That's number 1. Second thing is, what's always out in front of anything?
1.
Is that 1 to a negative power? No, so it's not going to flip. So these 4 go down, these 11 go down, what's left on the top? Poor little one dude, all by himself. Finally gets to show up though. Got to stay in the background, he's like, oh dude, right? Imagine that's what he would sound like. Alright, this should be quick. What about this guy here? If you have trouble with negatives, number 1, take care of that.
Yeah. Negative 3 plus 3.
Secondly, there's pretty much almost always a way you can sort of get around dealing with negatives directly. What do these 8x's want to do?
To the top.
Like I want to go up. What do these 3x's want to do? So I can rewrite this as this, and now there are no negatives left.
Oh.
So now I got x to the... And the reason, if I just did it directly from the beginning, what do I do with the powers when I divide?
Minus that.
Subtract them. What's negative 3 minus negative 8? Well, that's negative 3 plus 8. That's a lot of shit to do in your head. So to me, if I got negative powers, the very first thing I sometimes do is I flip them. So there's no negative to worry about. But maybe. I like how everybody does it. Yeah, Jeff. Welcome, class. Real quick, what's number 11? Very quickly. X to the 4. Right? Those 4 x's don't like where they are. So they're going to flip up. Number 11. That number. So if it's raised to a negative power, it just wants to flip to the other side. Okay. A couple more and then I'll let you guys out of here. Ooh, these look good. Ooh, I like number 1. Number 1 is really easy if you know what to focus on. Are there any like bases in number 1?
No.
No, so there's none of that work to do. It's purely the fact that it's convention to not end the problem with negative powers. So if there are some negative powers, you're not quite done yet. It's sort of like reducing a fraction, the same kind of idea. How many things are being raised to a negative power in this problem? 2. the 3 x's and the 2 z's. What happens to this 2 dude?
It stays there.
Stays right there. It's not being raised to a negative power. It's not attached to the z with glue or something. So what stays on top?
Y squared.
And what comes up top?
Z squared.
Those 2 z's come up. What stays on the bottom?
2.
The 2. And those 3 x's come down. So all I did was those 3 x's and those 2 z's, they just switched places. And now they're to a positive power. Now I'm officially done with that problem. Number 2, what did I just say a minute ago that will help us out with negative mistakes? What would I do first with number 2?
Either flipping it or adding.
Flip them, right? So that 5y, those 4 5y's, they want to go up. And those 3 2y's, they want to go down. So you get 5 to the 4th,
600.
y to the 4th, 2 cubed, y cubed. Yeah, 5 to the 4th is 625. I like that. 2 cubed is 8. And what happens with your y's?
Just
How many cancel?
all of this at once.
Yeah, there's 1 left on the top. Bam. So the whole idea of flipping the negative first really helps out in that kind of problem. Okay, yeah. All right. I'll see some of you guys in a minute. Do that quiz.
Oh yeah, that was that. They were.
But like that, so now I'm just like use that copy. I know